Three megatrends are setting the stage for the next major advance in business transformation. The first is obviously the cloud. The SaaS delivery model has taken over enterprise applications, delivering increased business agility along with reduced IT support requirements. In addition, the cloud offers a cost-effective location for hosting big data analytics and machine learning systems. The second trend is the adoption of smartphone and other intelligent mobile devices. Over 2 billion people, one-third of the world population, now carry smartphones. Along with smartphones have come social media and messaging applications that have revolutionized how people communicate and work together. 3/4 of the smartphone users already own and use these apps. Traditional media like email has gone mobile, with over 65% of emails now read on mobile devices, and more modern collaboration platforms like Slack beginning to set records for enterprise adoption. And the third recent technology trend that sets the stage for this next advance is the Internet of Things. Thanks to low-cost sensors, actuators, and radios, as well as ubiquitous connectivity, billions of devices are now connected to the Internet. These devices extend the reach of the Internet from the digital world to the physical world. These devices also generate massive amounts of data that will be available to help organizations serve customers better and improve their efficiency. But as impressive as these new technologies are, there is one opportunity they do not address alone. Mobile devices and modern messaging platforms enable people to always be connected so they can collaborate with other people more efficiently and effectively than before. And IoT has extended the world of systems to include billions of devices that enable systems to share data in real time, dramatically extending the reach of the automation. But what these two trends do not accomplish independently is a third scenario, where people not only collaborate with people and systems with systems, but people collaborate with systems. This third scenario, real-time collaboration among people and systems, represents the next great opportunity to improve customer engagement and improve operating efficiency, as numerous remaining unsolved business problems can only be addressed by people and systems working together in real time. To address this opportunity, Vantiq is a software solution that extends new technologies such as mobile and IoT, as well as existing technologies, cloud and legacy applications, to enable intelligent interaction between people and systems. Let me introduce you to the Vantiq Real-Time Collaborative System. Even though we're just coming out of our initial build mode, we are already seeing opportunities in multiple industries where Vantiq real-time collaborative systems are improving operational efficiency to reduce costs, increase customer engagement to drive new revenue, and create new business opportunities. So let me introduce you to a real-time collaborative system. Acme Energy has a variety of vendor-instrumented devices. For example, compressors from General Electric and Caterpillar. Issue is General Electric and Caterpillar want access to this data, but Acme doesn't want to provision them on their internal network. At the same time, Acme requires aggregated visibility on all these instrumented devices. This is to enable maintenance planning, to provide oversight on vendors, to be able to correlate devices with other systems, and potentially other types of capabilities down the line, such as machine learning and predictive maintenance, potentially automated field service work, and integration with other enterprise applications such as SAP and potentially human resource systems. So the requirements for Acme are really pretty simple. How to manage vendor access to device data based upon isolation from Acme Energy's internal network, as well as providing isolation between the vendors such that General Electric cannot see Caterpillar's information. Provide real-time aggregated visibility to all connected devices by Acme personnel. Third, to evaluate device performance and status based upon vendor-supplied thresholds and tolerance, which are now being made available as part of this trend in the Internet of Things. Fourth, to provide the ability to correlate devices from different manufacturers, for example, GE and Caterpillar. And then fifth, to provide device connectivity from a range of different protocols. But perhaps the best way to show you what we mean by real-time collaborative systems is to show an example. On this image, we see a contemporary solution. Acme Energy, a large energy provider in the Southwest, has a variety of vendor-instrumented devices. compressors from General Electric and Caterpillar. These are located in pumping stations located across the state of Texas. Both GE and Caterpillar want access to the data on their particular machines, but Acme does not want to provision them on their internal network. At the same time, Acme requires aggregated visibility on all the instrumented devices. This is to enable maintenance planning, provide oversight on their vendors and suppliers, to correlate devices with other systems, and potentially down the line to provide trained machine learning and predictive maintenance capabilities down to the edge, to provide automated field service work order creation, and potentially to integrate with other Acme enterprise applications such as ERP and human resources. So we have 5 major requirements here. One is to manage vendor access to device data based on isolation from Acme Energy's internal network, and isolation between the individual vendors such that GE can't see Caterpillar information and vice versa. 2 is to provide real-time aggregated visibility of all the connected devices by the Acme personnel. 3, to evaluate device performance and status based upon vendor-supplied tolerance and thresholds being made available as part of this new era of the Internet of Things. 4th, to provide the ability to correlate devices from different manufacturers, GE and Caterpillar, to ensure operating efficiency. And then 5th, to provide device connectivity via a range of different protocols, ranging all the way from the edge device all the way up into the cloud. This is a real-time collaborative system. We've actually built a lab setup with one of our key partners on the edge connectivity side. This particular partner has gone ahead and provided connectivity to 2 devices which are emitting data. That data happens to be speed, RPM, and amperage. This is very similar to other applications we've deployed in production, such as at M-Factor. So what we actually have is a Dell gateway box with Vantiq installed as a virtual appliance on the gateway. Our partner processes stream data from the various devices and provides these as an event stream to Vantiq. We filter this device information through a secured network interfaces separately to GE and Caterpillar, as we'll see here in a moment. The endpoints in the graphic represent the manufacturer's actual computers. In addition to providing visibility to the RPM and amperage readings, we can also run analytics on the edge to enable proactive maintenance and alert Acme to potential issues. So let's take a quick look at this particular scenario. What we're actually looking at right now is the dashboard. This dashboard was actually created using the Vantiq development capabilities. We're actually going to start the 2 devices, which we can actually see are publish events. And here in a moment, we'll actually see an uptick based upon the readings from the 2 devices. So we've now seen the GE compressor come online, and we've also seen the Caterpillar compressor online. Although we've enabled starting these devices, this is a privileged operation. Acme could enable this functionality or simply provide viewing of the device output. So in this case, this would be a privileged operation, only available for specific users. We can see both device level views of the data as well as the aggregate, and the aggregate information is located in these 2 graphs, where we're actually pooling together the information from both of the 2 compressors. The dashboard component that you see here allows us to build different visual representations as needed. Bar graphs, pie charts, columnar graphs, maps for geospatial recognition, gauges, etc. We additionally have a capability built in for doing mobile collaboration, which we'll show at the conclusion of this demonstration. But let's take a look at what Acme would actually go ahead then and see. If we are looking at Acme, Acme wants a view of everything that's going on. So here, in fact, we're actually taking a look at the aggregate view of all of the information available to Acme, both the power aggregate status and the speed status. And we can see here Speed Motor 2 and Power Scout, each of these representing different devices. The 2 tabular views that you're actually looking at are showing aggregated speed and amperage as the data streams come from the individual devices. These event streams are time series-based data, which allows us to use rules automation logic to provide processing for example, decisions or recommendations to react to specific events. Additionally, based upon this processing, we can as well talk to external systems. For example, if we've determined that a particular device performance seems abnormal, we could generate a work order for a service management system such as ServiceMax, or integrate potentially with an ERP, for example SAP, to support data enrichment and potential work order generation. We could also enable an enterprise-level view by aggregating the information from all of the similar devices to provide management visibility over the plant using intelligent filtering. But what about GE? GE should only be seeing GE information. And as we can see here in the graphic, GE is now being given a privileged operation to only see the information that's arising on their specific channel. They have no visibility of the Caterpillar information. So the data stream has effectively been filtered and isolated. This is what we're seeing here with a variable speed motor compressor, and the graphic kind of illustrates this point. This is simply enabled using rules and publishing and logic to private topics which can only be accessed by GE. Similarly, Caterpillar has the similar kind of view where we're actually going ahead and pooling information from different compressors, and as we can see here, variable speed motor 2, it's going ahead then and filtering and isolating that information such that General Electric cannot see it, but Caterpillar can. This provides an ability for Acme Energy to go ahead and both provide isolation of these two individual data streams as well as potentially monetization. Overall, as we've kind of discussed, this is really what we're looking at. We have the capability to go ahead and show different devices sitting out on the front end, in this case compressors, working through a variety of different protocols through a connectivity vendor, which then brings that information up into Vantiq, which is the real-time collaboration system. What I'd like to do now is to show you how this works from the standpoint of the mobile field technician. Remember our initial discussion about what we mean by a real-time collaborative system? It's not just people collaborating with other people or systems integrating with other systems. It's people being able to collaborate with systems and devices as well as other people to affect solutions in real time to specific problems arising as a result of a given situation. So imagine, if you will, the field technician that's called out to Acme Energy because of a performance anomaly of some sort in the compressor. Once they arrive at Acme Energy, they're going to go ahead and actually click the Vantiq application. Now, this application could be rebranded as needed for a particular organization, and we're simply using the default capabilities. So when he arrives, he has the ability to initiate a collaboration with the head office. So this could be him talking back to the service organization or potentially even to customers through a publish and subscribe event back on Vantiq. First thing he's going to do is he's going to start the collaboration. And he's simply going to click on particular options and actually start up the particular application. Now, as we can see, at that particular point in time, the field technician has received a notification. If he clicks his inbox, you can see the fact that there's a pumping station instant of some sort. And if he clicks on that pumping station instant, it'll go ahead and give him some basic information. The motor is malfunctioning. Please tap that he's arrived at the client location to report when he's in the data center and he's in a position to actually start working on the motor. So he indicates that he's arrived. This could be sending geolocation information back to Vantiq so that we could do, for example, location-based navigation of the individual to the given motor. But at this point, he's going to receive instructions on what to do next. So the first thing that's going to occur is he's going to be asked to find a specific motor with a particular serial number. All of this can be automated through the system on the back end where that service order has been initially generated, potentially from Acme Energy. And the first step will be to actually scan in a barcode. So we actually have a barcode. And at that point, we've captured the specific barcode. The field technician now is not quite sure of what to do next. So first he's going to go ahead and he's going to take a look at the specific document that relates to that particular motor. And he can click in on his cell phone or his iPad, find out specific voltages that might be appropriate. And potentially at that point, he can indicate that he's either fixed the problem or no fix has been found. And if he clicks no fix has been found, it'll go ahead and revert that particular ticket to Tier 2 support. At the same time, as we can see here, at the same time, we can go ahead and acknowledge that event. But what happens in the other case where he's able to actually fix it? He does the start. We run through the same identical steps that we saw before. We scan the barcode in at this point. And he indicates that he fixed the problem. And at this point, he gets a message back. The incident has been closed. This is what we mean by real-time collaborative systems. It's in fact the ability for people and systems and devices to all collaborate together in real time to solve problems. Real-time collaborative systems, a step into the future. Please visit the Vantiq website for more information.